In this session, we are going to talk about the Amazon Auto Scaling. Amazon Auto Scaling is a service which allows to add new EC2 instances based on the conditions defined. Before we move on to auto scaling, we would first try to understand what are the types of the scaling possible in regular world. We would understand what is auto scaling, what are the types of auto scaling, or how do you achieve the auto scaling, and we would go a little deep down about the auto scaling too. Let's see first what are the types of auto scaling in the market. Suppose you have a M3 dot medium instance size and you have a EBS, that's a root volume of 40 GB size to that. Now if you want to increase the capacity because your load is increasing, one way is from M3 dot medium you change the size to M3 dot large. To change the size you have to stop the instance and then change the size, provided this is an EBS back instance. Yes, if you want to change the size from 40 GB to 80 GB, you can also do that. You take a snapshot, you create a new volume of 80 GB, attach as a root volume. But changing the instance size or changing the volume size, in these two cases, it would require instance to be stopped temporarily and then the size would be changed. But that is possible. If you can do it in a off peak hours or something, you can back up. It's a possible thing. In another case, you want to change size from M3 dot medium to M3 dot extra large again by stopping server. Yeah, if you don't want to remove the original size of the EBS volume, you can attach additional EBS volumes also. You can rate them and then you can make them as a one EBS volume. All these cases are case for the vertical scaling. In the vertical scaling, you add resource vertically to the your current infrastructure. Whether you add memory, you add compute power, whether you add storage, all the cases are of the vertical scaling. Vertical scaling has some kind of a limitation because one limitation we just saw, it may require the instance to be brought down. In some cases, there is a threshold. Beyond that, if you keep on adding more resources, it may not improve the performance because eventually it's a single machine. A single machine has its own limitations, which might not work beyond certain capacity. So when you think about M3 dot extra large, M3 dot large, in both the cases, this is how it's going to work. Let's think over the another option that is known as a horizontal scaling. The horizontal scaling case, you add more resources horizontally to your fleet. So you have one M3 dot medium, you add one another M3 dot medium, you add another M3 dot medium. All three are managed by the elastic load balancer. So suppose you have a 10 requests coming up. Now even if you have a 300 requests coming, it would be evenly distributed among each machine with the 100 requests. So that's the horizontal scaling for you. Amazon Auto Scaling helps you achieve horizontal scaling. It adds more resources horizontal to your fleet, and you can also make them part of the ELB automatically, which allows you to scale horizontally. And believe me, the horizontal is the go-to thing for you because if you want to add more and more from 5 to 10 to 15 resources, that's a possible. Plus, it does not need any downtime and it doesn't need or it won't have any capacity threshold like a vertical scaling. You keep on adding, it would work perfectly for you. Auto scaling helps you achieve horizontal scalability for your applications. It's a perfect case for the high availability. It can scale up and scale down EC2 capacity automatically based on the conditions defined. You can manage your desired capacity. Now, what is that? When you make an auto scaling case, it would have three kind of a parameters: minimum size required, maximum size required, and desired capacity. Minimum means it would never go below those many numbers. So suppose at any moment you think I need two EC2 instance running. So at auto scaling level you define that I need two as a minimum. Now due to any conditions it would keep adding more resources because there is a load increase something. What happens if there is a DDoS attack and it keeps adding more and more resource? You don't want to do that. Or there is a known case because you know there is a virus scan going on. It's not a real increase in the load, but my CPU is behaving oddly. What you can do is you can set up the maximum limit also. You can say my maximum limit is 8. So when the load increases, it keeps adding more and more resources. So from 2 to 3 to 4 to 5, it would not go beyond 8. It would stop at 8. So this way you can control. And at any moment, how many instances you want, that is defined by the desired capacity. We would see in the demo how can you scale up, scale down, how can you define the minimum size, maximum size, and the desired capacity. But it's important to understand these are the three parameters: minimum size, maximum size, and the desired capacity. And with this, you can see you can increase or decrease capacity seamlessly. Now that's why this is the perfect case of the cost optimization. You would say, how would it optimize my cost? Imagine if you have 5 instances. Now, for these 5 instances, you might have to, you don't want the 5 instances running all the time. You say at any time keep two running. Whenever required, load increase, add one, two, three more instances over there. If you were in your own data center, you might have a procured capacity as per 5 instances and it would running. Here, you are running only 2 instances. As and when load increases, you add more resources. As and when load decreases, you remove the resources. And beauty of Amazon is you pay for only what you have used. So you would be paying for those 2 3 instances only when they are available or only when they are being used. That case, you would be paying for those additional 2 to 3 instances for some few hours only. That's why it's a huge cost optimization for you too. Autoscaling helps you to achieve the best of the high availability because it does keep check of the health of the instance, and even if it finds any of the instance unhealthy, it would terminate that and launch a new instance for you. You will read a little bit more about that in the future. Also, if you think, it helps you since it's a scalability. So if one zone goes down, so that instance stops behaving, it would automatically scale up because the CPU load increase, something like that, and it would help you achieve high availability and disaster recovery too. Autoscaling is ideal for hourly, daily, weekly variability. If you have a load, something which is in a spike, something like this, that's not the case. The reason is by the time it spikes up, you are about to spin up a new instance. It has spiked down, it has come down, and it's about to be terminated. Then again it spiked up, it is about to be launched. So you have to find a pattern and baseline something, and then only you should be setting up the auto scaling formulas or events to come across. It works with the ELB and the CloudWatch perfectly. We'll be seeing in the demo how does it help you. And the most important, it does not cost you extra. It's a free of the cost service. So auto scaling is elastic by nature. We know it's elastic. It can add more compute power elastically, and that's why it helps you in the dynamic scaling. You want to add the resource, you want to remove the resource, it helps you for that. And that results in your cost savings because you are paying for the resources which are added only when required. So helps you for high availability. The important point is it works within a region only. So auto scaling is particular to a region. So whatever condition defined would be part of that region only. Whenever load increase, it would keep on adding. Whenever load decrease, it would keep decreasing. It works in that way. Auto scaling, how do you work with that? So there are the few steps you need to follow when you are working with auto scaling. First and foremost step is you create a launch configuration. So when you go to the auto scaling, there are two things you need to work. One is a auto scaling launch configuration, another is a auto scaling group. Now what is a launch configuration? You have to think what is the role of a auto scaling. It launches an EC2 instance based on the condition. Now while launching an EC2 instance, what all parameters do you need? You need instance size, you need key pair, you need AMI because it would be launched from that, you need security group, You need EBS volume and a few parameters which are required to launch an EC2 instance. While launching an EC2 instance, we have followed these steps multiple times. That is the exactly thing you define in a launch configuration. Here you identify the EC2 runtime parameters. It's a very important. The AMI ID is the most important because you want that I have a application setup with the Apache web server. Now I want to do that the whenever there is a load increase, it would add a Apache server over there or new instance over there, which is the Apache server already running part of that. What you can do is you set up an EC2 instance, install Apache over there, configure that the whenever the instance boots up, Apache starts automatically, and create an AMI out of that. Provide that AMI to EC2 launch configuration. So in future, whenever autoscaling launches a new instance, it would launch this also. It would also launch this instance, and where the Apache is already installed, Apache would start automatically, and you make it part of the load balance, it would start running for you as it is. It's very important you identify the runtime parameters, and that would be defined based on your AMI. That's the one key aspect. Apart from the AMI, you would be selecting more parameters like key pairs and the security group and the EBS volume size and a few more. The next step is, and here you are just identifying parameters. The next step is you create an auto scaling group. In the auto scaling group, you would be selecting or taking this launch configuration as part of this, as well as you define maximum size, minimum size, and desired capacity as part of this. You also define which all zones does this. I'm talking about zones of a region, not multiple regions. Zone of a region. Which all zone this auto scaling be part of. So what happens? As soon as you create an auto scaling group, it would launch an EC2 instance. How many instances it would launch? It would be based on the desired capacity. And if you have not specified desired capacity, then what is the minimum capacity you have specified? Based on that, it would launch EC2 instances. Those instances would be launched based on the launch configuration parameters you have selected. It would select the same AMI ID, same key pair, and everything it would take out of that. So your first step was creating a launch configuration. Second step is creating an auto scaling group. Once all this is done, you can create an auto scaling policy. In the policy, you define that whenever there is a threshold above 60%, below 60% something, or based on time, you launch a new instance. So as soon as CloudWatch detects the condition breach, it would notify auto scaling and it would execute this scaling process. When the scaling process is executed, that also be part of ELB. You have configured that. So everything works seamless for you. Launching a new instance, and even if the vendor it goes below the threshold, it would terminate the instance also. So when you think of the auto scaling process, the important steps are creating a launch configuration, creating an auto scaling group, and creating a policy for that. Auto scaling with the elastic load balancer gives you a perfect resiliency. So what happens? Suppose auto scaling has launched an EC2 instance. Now that instance is also added to the elastic load balancer. Autoscaling itself also performs the health check on the instance. Now we know ELB does perform the health check on the instance. Autoscaling also performs the health check on the instance. In this case, as soon as the instance becomes unhealthy, ELB would stop sending traffic to that instance. ELB would stop sending traffic to that instance. We know that ELB keeps check of the health of the instance. When it's unhealthy, it stops sending traffic. And if it's unhealthy, autoscaling would terminate that instance automatically. And since it's a terminated, so your desired capacity has to be maintained. Autoscaling would launch a new instance as per the desired capacity. That instance would be part of the ELB again, and the whole thing starts working back to the normal. So even if due to any zone outage or any other outage Amazon level instance goes down, ELB would stop sending traffic to that. Auto scaling would terminate and launch a new instance for you. That would give you the case of the perfect resiliency. Auto scaling works in the three scenarios. Let's see what are the possible cases in this three scenario for the auto scaling. First is a based on the time. Scaling based on the time. You can create a schedule action. Suppose when you are doing your load monitoring with the CloudWatch, you feel that every day 9 a.m. the load increases and every day 5 p.m. the load decreases. What you can do is autoscaling allows you to scale based on the schedule. So you can create a schedule where based on that load it would automatically increase the capacity, based on the schedule it will decrease the capacity also. You can set up the time in Amazon Management Console. You can also set up, it's not a week, one day. You can set up that if it's a recurring, it's a one time, what you want to set up that, and based on this desired capacity, it would be changing that. So this is scaling based on time, where you know the pattern and you want to scale up, scale down, you can do that. Second is a dynamic scaling, where you want to scale based on the conditions. You don't know your application is working normally, but suddenly there is a huge hike on the load. Let's say at the 9 a.m. the load has increased by the 50% or 60%. At 5 p.m. the load has decreased by this something. It happens. Now, what would you do that? You would be creating a policy for scaling up and scaling down. You can say that, sorry, it's not a time waste. That's my miss. You can set up that, okay, when there is a CPU utilization. So if I say my application is working normally, my normal CPU utilization should be below 60%. Now, due to certain conditions, if the load is increases and it stays there for a longer period, you can set up a policy which would scale up automatically based on these conditions. So you can create a CloudWatch alarm which says that whenever CPU is more than 60%, notify auto scaling. Now, this auto scaling would then take up and launch a new instance as soon as it receives a notification from the CloudWatch. You can also set up a bottom threshold that whenever it's below 20%, again notify auto scaling. So whenever it goes below 20%, it would then also terminate the instance. So you can set up the scale up policy and scale down policy. In the same game, third is a manual scaling or the constantly growing scaling. When you want to follow the certain pattern, how you want to scale up or scale down, you can do that. And this is more about, you know that okay, this is the time I want to increase the load. You don't want to wait for any conditions, you don't want to wait for any time base, you want to do it manually. This is the case for you. It's very easy. You just go to the CloudWatch, you just go to the auto scaling and change the desired capacity to your required, and it would be based on the desired capacity, it will scale up or scale down. The one of the exact example I would say, due to certain conditions you have set up that okay, it should scale up, but you don't want to set up the scale down policy as of now. So what you've done is when the load increase something happens, you would be scaling up. Now after some time you think okay, this is the time now I want to scale down. You can go and manually change the policy. Again, as long as there is a less manual intervention, that is the best policy. But in some cases you might require that. So you can think of that option too. This is a simple architecture of the how the auto scaling things would work. You would have a website, something like example.com, that is being mapped to some IP address of the load ELB, and I would say not IP, it's a DNS using Route 53 service. With this elastic load balancer would be sending the request to the instances, and there is an auto scaling configured as part of that. When auto scaling is configured part of that, and whenever there is a threshold or some breach of the conditions, it would add more resources to this auto scaling group, and that would be again part of the load balancer. So when the load increase over the example.com, automatically it would be taken care by the using elastic load balancer, auto scaling group, and CloudWatch. It can scale up, scale down based on the policy defined, and it receives the alarm from the CloudWatch. Let's try to understand a few vocabulary of the auto scaling. Auto scaling has a launch configuration. The launch configuration we spoke about, it's a first step to create your auto scaling where you define what all runtime parameters it should use to launch an instance. This is the EC2 runtime parameters. Then it does have an auto scaling group too. Auto scaling group is nothing but a representation of a multiple EC2 instance. So it uses the launch configuration to launch an instance, but what would be the max size, minimum size, what zone it supports, that all thing you define in the auto scaling group. As soon as the group is created, it launches a new instance. You also have a policy. A policy is that you define that based on the response from the CloudWatch, what action should auto scaling take, whether it should scale up or scale down, that is defined in the policy. A trigger is nothing but the what you receive from the CloudWatch. When a CloudWatch receives you receive an alarm from the there, it would be part of that. It is part of a CloudWatch alarm and auto scaling policy. So as soon as the alarm crosses the threshold, it notifies auto scaling. Auto scaling policy would be executing the thing. That's the whole thing is called as a trigger. And auto scaling keeps checking the health of the instance regularly. It does perform the health check and keep the check of the status of the health. So as soon as it finds any instance unhealthy, it would terminate that and launches a new instance on place of that. What are the use case for the auto scaling? It's ideal for the web tiers or stateless tiers. So you should use it for the Apache, Nginx, Tomcat, JBoss, wherever you have a web server tiers, it is required for that. Can you use it for the load database? You cannot. We'll see in a moment. So ideally, when you have web servers which are facing the external world traffic, or when you have a stateless tiers which does not manage your state, that is the case for the auto scaling. We learned the three types of the scaling: manual scaling, scaling by schedule, and scaling by the policy. It's a recommended that you should have a two policies, one for scaling up and one for scaling down. Let's try to see a little bit of the scaling in depth. The scaling is recommended when you have a gradual rise or the gradual low. If you have a spiky requirement, scaling is not for that. Yeah, there is a spike of the increase, scaling is that. But what I meant is spike up, down, up, down, up, down. That is not the case for the scaling. You can create up to maximum 100 launch configuration as part of the auto scaling. In some case, you want to suspend the scaling. You want to resume because you are doing something new installation. You are doing something over the instance. You know that. So you can suspend or resume the scaling also. You can have maximum 125 scheduled actions for auto scaling group. So every day it can have allowed 4 actions per day. That's a possible. Also, when auto scaling is terminate the instance, you can define in which way it should terminate. That is the oldest instance first, newest instance first, instance with the oldest launch configuration first, or instance which is closest to instance R, that is for the pricing base first. You can define that also, and we would see that also in our demo. We know that EBS back AMI boots faster than the instant store back. Ideally, word should be instant store back AMI. And even it's easily to make also. So that's a recommended to use the EBS back AMI as much as possible. Yeah, you cannot modify your existing launch configuration. So in case you have created a new AMI and you want to change the launch configuration, what you have to do is create a new launch configuration and modify the auto scaling group with this new launch configuration. You cannot update existing launch configuration. You can use spot and reserved instance also with the auto scaling. Auto scaling works across the multiple availability zones within a region only. It works seamlessly with or without ELB. In some cases, you might not need ELB because you're doing some Hadoop or batch processing. You can use the auto scaling for that purpose also. Auto scaling checks the health of the EC2 instance regularly. It does perform the health check, and during the health check, if find the status of the EC2 instance okay, then it's a good. If it also performs the health check of the ELB also, if it find the ELB health check in service, then it's a good. If it find it's not running, because what happens, an EC2 instance is registered with the ELB. Now, when it's registered, the status of the EC2 with the ELB would be in service. Due to any reason, if it's out of service, auto scaling would mark that instance unhealthy and terminate that. If an ELB is unhealthy, all instance will be also marked as a unhealthy. Auto scaling does also support its own metrics for the CloudWatch. They are like what is the minimum size, maximum size, desired capacity. Yes, if you have enabled the detailed monitoring with the auto scaling for EC2 instance, that is a chart. Auto scaling should never be used with the database unless it's a read-only data. Why? Imagine a case you have a database. Now, suppose the load rises and you say, I want to spin up new database instance. What would that result? It would result in inconsistency because some data comes to this machine, some data comes to this database. The data is not consistent. You cannot have a two instance. So, and plus auto scaling can terminate this also whenever this load decreases. So your data would be lost. Since it's a persistence tier, auto scaling should never be used with the database. If you have a read-only database, then only you can do that. So what happens that your data is coming only for the reading part. It's not doing any insert, dealing, anything, update part over there. Then it's okay because if you have a 3 instance, 5 instance, even if the one terminated, you don't mind because it's a read-only thing. When we go to the RDS, we will see that read-only part too. If you have a critical configuration like log, audit trail, something coming to the EC2 regularly, you should plan keep moving them to the S3 at regular interval. You should also optimize your resources after monitoring pattern. You should keep monitoring your resources regularly, and whenever you find upward downward scale, you should add or remove the resources too. So this is all about the auto scaling in the theory.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.